Good morning and big welcome also from my side. I am Félix Urbain, Senior Consultant at Nordic Innovators and our EU program expert for climate, energy and mobility related EU projects. Before joining Nordic Innovators, I pursued a scientific engineering career, first as a PhD student in the topic of green hydrogen production. I then also added a postdoctoral study phase where I also did research on other hydrogen topics such as storage, distribution and end use. And since April 2019, then I work for Nordic Innovators, and based on my background, mainly on large-scale green tech EU funded projects. For the presentation, I will decrease my size here so that I won't distract the vision on the slides. So the agenda of today's webinar looks as follows. I will briefly introduce Nordic Innovators to you, to then directly jump into the clean hydrogen joint undertaking call, its strategic priorities and ambition. I will of course also elaborate on the open calls for the September 20 deadline, and then also talk about the rules, evaluation criteria and the general conditions before then closing up and starting the Q&A session. So who are we? Nordic Innovators is a consultancy based on European and national funding programs. We support companies, research institutions and universities. Currently we are 65 people from 23 different nationalities. We like to say that there is actually no European language that we do not speak in-house. So that's a nice unique value we can provide. Among our core business service areas listed here below, we can list, of course, funding strategy. We want to be the trusted advisor for companies in mapping the right funding strategy adapted to the company's needs. We, of course, then also prepare funding proposals and also support or advise companies in the project management and reporting phase. We also offer services in the business consulting and investor capital, and based on our more than 8 years operation in these different areas, we managed to establish, let's say, a wide portfolio of company networks that we can offer or leverage to offer partnership networks, for instance, to establish consortium for projects to new clients. Who chooses us? As said, no, we advise SMEs, large-scale enterprises, research and development institutions, and universities. Here's a snapshot of companies and universities we have worked in energy projects. As you can see, and some of the logos might sound very familiar to you. Why do these companies choose us? Obviously, because we help them to win EU grants. But as you might know, winning an EU grant is just a consequence of an extensive prior work, and our added value, I might say, is provided during the proposal development phase, where we really go through a lot of aspects with our clients. We starting from picking the right project idea, linking it to the right and adequate EU program. We then also, based on our, let's say, in-house technical and business expertise, we help clients to assess not only the project, its fit, but also in the case of consortium, we assess the strength of the consortium upfront. We have, of course, a systematic writing process in place, which helps us to set an attractive narrative for our clients' projects. An added value is that we speak the evaluator's language, so we know what evaluators will want to see in the projects, and we use space of the proposal templates very efficiently. We, of course, always aim to follow the timelines, to submit on time, and all these aspects are ensured because in the end, our client's success is also our success. So now on the Clean Hydrogen Joint Undertaking work program, this is an EU body in the form of an institutional, private and public partnership. On the EU public side, it is composed of the European Commission, and on the private and the EU private side is composed of Hydrogen Europe. This is an industrial association with more than 300 members, and the Hydrogen Europe Research Association also with more than 100 members. And since 2008, this partnership paves the way, so to say, for green hydrogen technologies in order to make a high impact on the current green transition. The partnership tries to do this by unlocking up to 2 billion euro, which is planned until 2027. The Clean Hydrogen Joint Undertaking's priorities and ambition are very much reflected in the European climate law, defining the climate goals for 2030 and 2050. And based on this, the rollout plan for renewable hydrogen technologies defined in the joint undertaking work program looks as follows. So until 2024, it is expected that at least 6 gigawatts of hydrogen electrolyzers will be installed in Europe, producing more than 1 million tons of hydrogen. Yeah, these are also combined with the so-called hydrogen valleys. And then the plan, of course, for 2030 is even more ambitious. They target a 10-fold increase in the production of hydrogen, so reaching 10 million tons in EU. And then until 2050, these technologies should further be matured, further be deployed, so that in the climate neutrality scenario, hydrogen can cover more than 12% of the total energy demand in Europe. This ambition is backed up, of course, by the European Hydrogen Strategy, published in July 21, the Fit for 55 package, and the Hydrogen and Decarbonized Gas Market package from December last year. The joint undertaking, so this call or this work program is based on a 14 years legacy. So there have been 2 prior work programs, the fuel cell and hydrogen joint undertakings, funding up to now 287 projects with a total grant budget of a bit more than 1 billion. And these projects the projects that have been funded went really from research-based projects, so low technological readiness level, TRL, to delivering fuel cell and hydrogen solution in the market, so higher TRL. This as depicted here. So this really goes from manufacturing, material science to large-scale hydrogen valleys that can be funded through this work program. What type of actions, so projects, are funded and what are the associated funding rates? Here, just to know, this is vocabulary or jargon of the European Commission. They say actions, which means projects. So the first type of action, first type of project is the research and innovation action, RIA. These projects aim primarily to establish new knowledge. So really explore the feasibility of something completely new or something significantly improved. Technology, product, process, service. And in concrete terms, this means that this project type allows for basic and applied research. Technology development is also allowed and may include even testing, demonstration of a smaller version of the, let's say, commercial scale system. These testing or demonstration should happen in a laboratory environment or a simulated operational environment. Here we talk of targeted TRL levels of 5 to 6. Very attractive funding rates, so 100% of the project budget for all participating entities can be funded in RIA projects. Then we have the second type of projects funded, which are the innovation action projects. These projects usually are a bit more mature in terms of technology development. These projects should not entail basic research, not too much development, but should really target a commercial scale, let's say, ready product, by producing plans, designs, constructing the processes, the prototypes. And then also in concrete terms, this means that these projects must include prototyping, testing, demonstration or piloting of a large-scale product. So validated in a real operational environment, and also already touch upon scalability, so market replication at TRL 8. The funding rate for profit partners is 70% of the total project budget. Still, also for ER projects, non-profit legal entities will receive 100% of their budget costs. Then there's also a third type of action, the coordination and support actions, the CSAs. These projects exclude research and development activities, but primarily target to promote cooperation between legal entities, either from member states, from EU member states, or associated countries. And also with attractive funding rate of 100% for all participating partners. Just briefly, this might look very familiar to most of you, but just to have the right structure in mind when further talking about open calls. So RIA projects usually start at TRL 3, TRL 4, so experimental proof of concept done or a technology already validated in the lab, and then target the TRL 5 and TRL 6 as said. ER projects, on the other hand side, are more mature or should bring the solution, the technology, the process, service, whatever is developed in the project to a higher TL level, so to a more mature state. In most ER projects targeted TL 8, so a system that is really complete and qualified and so to say fine-tuned and ready to be deployed at commercial scale. So now let's have a look at the open calls for the upcoming September 20 deadline. Sorry. There are actually 15 open topics with an available budget of 121 million. The calls are distributed in several, so to say, topics listed here. So topics are renewable hydrogen, hydrogen storage and distribution, hydrogen end use, cost-cutting issues, and hydrogen valleys. Starting with the renewable hydrogen topic, call 014, targeting design for advanced and scalable manufacturing of electrolyzers. On the upper right, you see in the blue box that they expect to fund 2 projects with 2 million project budget each. This is a call for RIA projects, so targeting a TRL 5 level at the end of the 3 years project. The aim is to further mature, develop novel components or manufacturing processes integrated in a demonstrator stack. The objectives of this call, as listed below, they target new surface coating technologies, advanced manufacturing processes, for instance, 3D printing that is applied to improve the manufacturing throughput, also the level of automation to produce the stack, and of course, all should target or should entail reduced manufacturing times and costs. There's a specific requirement on the consortium composition for this call, which should include at least 1 electrolyzer OEM, 1 actor also from the manufacturing sector, and at least 1 SME. The second call is 015, targeting the scaling up of cells and stacks for large electrolyzers. You see on the right, they expect only 1 project to be funded with a total budget of 6 million. Again, it's a low TRL project, so a research and innovation action project. The aim is to design and construct cells that can provide a 10 megawatt capacity stack. What is the objectives? So scaling up the cells by 2-fold, higher current densities. There are even specific let's say, key performance indicators in the call text of 2.4 amps per square centimeter, and also reducing the catalyst materials is one KPI in this call. It's also said that the scale up should target an appropriate balance of plants, compact design, minimize the weight and footprint of this stack is targeted. And then in the end, this call should answer the question if several short stack or a single stack is the most appropriate solution for reaching a 10 megawatt capacity. And here questions on optimal sizes from a scientific, engineering, logistic, but also economic perspective should be answered. Still in the renewable hydrogen topic, we have two more calls for September 20 deadline, the 018, which targets integration of multi-megawatt electrolyzers in industrial application. You see this blue flag, so and also seeing the total budget of this call. This is a so-called flagship project of this clean hydrogen joint undertaking, and also an innovation action. So a more mature project, which is expected to have a significant impact in accelerating the transition to a hydrogen economy. It's to demonstrate electrolyzer technology beyond state-of-the-art, at least 25 megawatt electrolyzers, low temperature or hybrid temperature can be targeted. Regarding innovation in this project, the call text gives some hints how consortiums could target innovation, possibly by supplying, for instance, 2 customers or using oxygen and heat. Seeing if grid balance services can be included, and of course footprint reduction is always sought after. This project should also include a go-no-go decision milestone, after which successful, let's say, completion, the 2 years operation should be included in the project. A tip is to investigate synergies with other ongoing projects or partnerships, for instance, the process for plant or the clean steel partnerships. The last open call in the renewable hydrogen topic is the 0110, where it's about demonstrating offshore production of green hydrogen. Again, a flagship project with a total available budget of 20 million. One project will be funded, and it's an innovation action, so also a higher TRL 7-8 target in this call. The call text, when you read it, it's on purpose kept very broad. So they say that the aim is to design, construct, and integrate at least 5 megawatt electrolyzer in an offshore infrastructure. Here also they leave it a bit open, so it's either to reuse offshore oil and gas existing infrastructure, integrate electrolyzers, and then also import, let's say, renewable electricity to drive the electrolyzer, or to develop a new electrolyzer, install it close to an offshore, for instance, wind energy farm, so used directly available renewable electricity, and then put more focus on distributing the produced hydrogen to shore. Of course, at such scale, the project should, of course, encompass safety aspects, remote control, autonomous operation, inspection and maintenance are key criteria and aspects to consider in this call. And then after design construction, it's also foreseen that 2 years operation is included in the project, just to assess the performance of this large scale project. Degradation in such a salty environment, OPEX costs, maintenance costs, overall assessing the economic viability of such a large scale electrolyzer in an offshore infrastructure is targeted in this call. The next topic area is hydrogen storage and distribution. There are 5 open calls for this topic. You see the first one, the 021, compatibility of distribution non-steel metallic gas grid materials with hydrogen. It's a TL5, so a RIA project, and only one project will be funded with a total budget of 2.5 million. It's about testing and improving the compatibility of the natural gas distribution network with hydrogen mixtures. So the target is to deliver an inventory of non-steel materials in the distribution grid first, and then on the second, test the effect of hydrogen and NG mixtures, starting with 20% and then also going up to 100% hydrogen mixtures. The final goal of this call is that a database of results is created regarding the gas grid metallic materials behavior in the presence of hydrogen. The call 024, ammonia to green hydrogen, so about hydrogen carrier, develop and test an improved ammonia dehydrogenation system. One project will be funded of up to 3 million. And this is again a more research-based research and innovation action project, where the work should focus mainly on the catalyst and the reactor design of the dehydrogenation unit. Some KPIs are also given, like for instance, the demonstration for at least 500 hours and producing at least 10 kilograms of hydrogen per day at atmospheric pressure. Also scalability, so the TL5 is already also touching almost a TL6 level here, because the scalability should also be an aspect to consider in this call. Scalability up to 100 tons of hydrogen per day should be demonstrated, or at least evidenced. Call 2.025, again, very similar to the ammonia, so another hydrogen carrier solution, which is the liquid organic hydrogen carriers, LOHC. And the KPIs are almost the same as for the ammonia call, the budgets as well. So one project will be funded with a 3 million budget, and again, it's a research and innovation action. Then the call 026, where it's about development of a large-scale liquid hydrogen containment for shipping. A bit higher budget is provided. Only one project again will be funded, but here the aim is to develop and validate containment concepts intended for bulk shipping of liquid hydrogen. This should entail concept selection for large-scale liquid hydrogen shipping containment, where aspect, of course, regarding safety, cost, and energy efficiency should be elaborated on. It's about finding the detailed and optimum design, construction, and testing of a scaled-down prototype of at least 10-ton liquid hydrogen capacity. And then this call gives a very specific objective, that the liquid hydrogen containment system should be approved by one of the major members of the IACS, so International Association of Classification Societies. The last call in this hydrogen storage and distribution topic is the 0211, development and demonstration of a mobile and stationary compressed hydrogen refueling solution for application in inland shipping and short distance operations. So it's the focus is either on a stationary pipe to ship, or on a floating ship to ship or platform to ship solution, where applicants must demonstrate a smart and safe logistics solution and develop also a market standard to support front-running shipping projects. So this, when reading through the objectives of the call, also including a techno-economic analysis, a standardization of the engineered solution, but also the relevant components. This is reflected in the fact that this is an innovation action, so targeting not a complete solution, but a bit more than just basic research and development, so targeting a TL6/7, I would assume. And the project available budget is up to 7 million, and of course, an innovation action. The tip also given in the call is that applicants might seek for synergies with the calls in May for this clean hydrogen joint undertaking, and one specific call was the 05, so hydrogen-propelled inland waterway vessels. Third topic is hydrogen end users. First aspect, transport application topics, the call 031. Development and optimization of reliable and versatile PEM fuel cell stacks for high power range applications. There will be 2 projects funded, each 3.5 million in budget, and it's again a more research development based project, so research and innovation action. The primary focus should be on heavy duty road applications. The main key performance indicator is that at least 20,000 hours operation should be achieved. Minimum is in terms of power is 5 kilowatt. The power density KPIs are also indicated. Here in this call, the focus should really be on the research at stack level. The membrane electrode assembly innovation is out of scope, which has been targeted by one of the prior calls. Another hydrogen end use aspect reflected in the call is clean heat and power. The 041 call, design and industrial deployment of innovative manufacturing processes for solid oxide fuel cell system and fuel cell components. It's about improving the automation of time-consuming manufacturing steps and time resource efficient quality control. So this is really a call targeting the manufacturing process. It's about automation, equipment, manufacturers is at the core of this call and should target adaptation development of manufacturing processes on a prototype tool. So already higher TL process measured by increasing the MRL, which is the manufacturing readiness level, very similar to the technology readiness level. The KPI is also indicated that the stack cost or production cost should be below 800 euro per kilowatt. The fourth topic is the so-called cross-cutting issues topic, where we have 2 available calls. The first one is a CSA, so no R&D, but more on the public awareness raising target. So it's called public understanding of hydrogen and fuel cell technologies. Again, very broad topic, but here it's about raising public awareness and trust towards fuel cell and hydrogen technologies and their benefits. Projects should evidence that they can improve or increase the understanding, improve public perception and attitudes towards fuel cell and hydrogen technologies, also building on learning from past and ongoing initiatives. It's about developing guidelines, good practices for raising awareness and trust, as already mentioned, and also setting up stakeholder engagement activities. The focus, of course, should be on the fuel cell and hydrogen technologies, and the target groups or audience is public and industrial stakeholders from different sectors and territories. The second call in this topic is the 053, named Safe Hydrogen Injection Management at Network-wide level, so towards hydrogen, towards the European gas sector transition. It's a research and innovation action project. One project is expected to be funded with a project budget of 3 million. The main aim is to develop technical documentation for safe multi-gas network management, of course complying with EU standards. Objectives include the development of methods, tools, technologies, guidelines, etc. for European transition and distribution network management and gas quality tracking. So it's about modeling the tools for a networks simulation, but also to mature technologies for the quality tracking and mitigation of various hydrogen concentrations, and also setting up databases, protocols, etc. That can help in the inspection of component behavior. The last topic And let's say the most, budget heavy calls is to be found in the Hydrogen Valley topic, where for the September 20 deadline, we have 2 open calls. One is the 061 call targeting hydrogen valleys at large scale. Again, this is a flagship project. You see the available budget for this call is 25 million. Only one project will be funded. It's an innovation action, so really targeting a TR8 level at the end of a 2 years project. Objectives is the production of at least 5,000 tons of green hydrogen per year, using new hydrogen production capacities, and also entailing, or let's say serving the GOs, which is guarantee of origin. So really having green hydrogen produced and distributed. Also a clear objective of this call to have at least 2 fuel cell hydrogen applications in at least 2 end-use sectors, so from energy, industry, transport. And then the demonstration should focus on existing and new hydrogen markets, of course, showcasing and assessing the economic growth potential, the impact, and replicability of the deployed solutions. Commitment of stakeholders for this innovation and action, especially for the Hydrogen Valley calls, is key, is highly important. So any form of endorsement of evidence that stakeholders are committed, power purchase agreements, offtake agreements, etc., is something that can be leveraged in this calls. Besides the grant, applicants should also, let's say, elaborate on the financing structure and the strategy describing the business model overall. Also including envisaged sources of co-funding and co-financing, and of course also the commitment of the respective finance stakeholders is key. The second call is Hydrogen Valley small scale, which on the contrary targets large-scale hydrogen valleys in area with no or limited presence of hydrogen valleys. This is different to the large scale. Also, as it is a small scale, lower budget, 8 million, only one project will be funded. The targeted production is at least 500 tons of green hydrogen, so 10-fold decrease compared to the large-scale project. But again, it's about having green hydrogen. The objectives, they supply more than one end application, same as for the large scale, and at least 20% of the hydrogen produced should go to this main end to 2 main end applications in this project. Regarding demonstration and the financing structure is very similar to the large scale call just mentioned above. So this has been the 15 open calls with the respective, let's say, budgets, TRL expectations. Now, on a more general term, I want to use the last part of the presentation to elaborate on the rules, evaluation criteria, and also deduce, let's say, more program-specific conditions for this joint undertaking work program. The applicable rules can be found in these 2 depicted documents here. So the general terms, general conditions are to be found in the Horizon Europe work program for 21 and 22, composed of different annexes touching upon admissibility, eligibility, capacity of the applicants, award criteria, etc., etc. And then the more, let's say, program-specific guidelines and rules can be found in the work program of the Clean Hydrogen Joint Undertaking, where it is elaborated on different eligibility criteria. For instance, maximum contribution per topic, which we have seen already, KPIs, target markets, requirements for co-funding and co-financing, and very important, consortium composition. There are specific calls where, for instance, also African countries can participate, low and middle income countries, countries that are not eligible We will touch upon this topic at a later slide, but companies that or partners that are not eligible for funding can participate, but must evidence how they will finance their part of the project. Some words on the general conditions. So a project is eligible when in line with the topic and core conditions. This is and objectives. This is I think the first let's say step companies, research institutions or universities should take when they are interested in one of the calls. So really read the call text and objectives. You should point per point be able to cover all the listed rules and objectives. The project consists mainly of two parts. Part A is an administrative and budgetary data form. We will see in more detail now what this exactly means. And part B, which is basically the proposal, the technical description, composed of three main chapters. Again, a project is eligible when it complies with the consortium compositions in research, innovation action and innovation actions. The rules are clear, written in stone, that at least one independent legal entity from an EU member state must participate, plus at least two other independent legal entities, which are either coming from a member state, from a different member state, or from an associated country, like for instance, Norway, Iceland, UK, or Turkey. The requirements for CSAs are a bit looser. So here it's at least one legal entity from an EU member state or an associated country. The project is competitive, when it's convincing, when it has a convincing so-called funding pitch. So when evaluators really see also guiding red thread through the proposal. When it has a well-balanced consortium, so it's not just to cover the above-mentioned criteria, but the consortium really should be complementary, should really cover all the needed work that needs to be done in the project. It should include a clear plan for dissemination, exploitation, and communication of the results. Exploitation of the results for the individual partners and conjointly as a consortium. Especially for the flagship calls we just saw, the project should consider a safety plan and provide guarantees of origin of green hydrogen. Also the Certify initiative or scheme is something to consider here, as well as further success evidences as mentioned. The stakeholder commitment evidence, like for instance, power purchase agreements. Some more details on how the proposal looks like in the end. So part A is an online form. This is filled out, it's an administrative and budgetary information filled out online. And part B, so the main, let's say, proposal document submitted as a PDF. Unfortunately, there's no separate annex, so no, for instance, also CVs, letters of intent, letters of support, memorandum of understandings, etc., cannot be included in an annex. If any, they must be included in the part B. On the upper right, you see that the different type of actions have different page limitations. CSA 30 pages, the research and innovation action 45 pages, and the ER projects have a maximum page limit of 70 pages. The main sections to consider is first excellence, where it's about the project objective and ambition, where also the methodology of the project must be elaborated on. Second section, very important, of course, is the impact section. So what is the project's pathway towards impact, and what are the, let's say, measures to maximize the impact regarding dissemination, exploitation, and communication of the achieved results. This section closes up with a summary, and then the third and last section is the quality and efficiency of the implementation. Here it's about describing a well thought through and efficient work plan with an efficient allocation of resources. So here the consortium, the well-balanced consortium will be analyzed by evaluators, and it's about the capacity, of course, of the participants and consortium as a whole to make the project a success. Some tips, lessons learned from many projects we have worked in. For the excellence section, of course, it should really demonstrate that this is a technological breakthrough. It's something novel, and also the TRL level, as stated in all the call text, must be evidenced, either by feasibility studies done prior to the project or whatever technical due diligence participants can provide. As I said, it's very important to have in mind call-specific objectives, define also feasible objectives and KPIs for this project, and KPIs related to both business and technology. The described methodology should be appropriate for the consortium constellation, sound, and should be resilient. Also, mitigation strategies for things that could go wrong must be elaborated on. And other aspects also need to be included as listed here. That's something evaluators will check and will look for. For instance, how is the interdisciplinarity guaranteed? Is social sciences and humanities integrated? What about sex and gender aspects, open science implementation, search data and output management? All these aspects need to be described in a sound way in the excellence section. Section impact, of course, it's to define realistic climate impacts within the project and beyond. So scalability post-project is very important to evidence. But also, not only climate impacts must be defined or described, but also other economic or societal benefits can be alluring to describe. The proposed DEC, so dissemination, exploitation, and communication measures, should be credible and contribute to a successful market launch and also a sustained market presence. This is very important. This is usually this section is usually making a difference between a good and the winning proposal. And of course, aspects regarding IP, IPR management strategies, and the route to market validation are important aspects in the impact section. Then on the implementation, so on the work plan, the third section, of course, the team, the consortium should be outstanding regarding quality, motivation, and also uniqueness. So again, as I said, this reflects my comment on not only covering the nationality, eligibility, but also the consortium must be well balanced. And on top, the proposed work plan should present an adequate timeline. It should be measurable and timed by defining really key milestones. Even some calls, as we saw now, have this as a mandatory aspect in the calls, having these go, no-go milestones before starting, for instance, an operation. The work plan should be coherent and well-defined and well-analyzed. Risk management section must be provided in the proposals. And then, of course, the proposals should entail an appropriate and effective allocation of resources. Just briefly on the evaluation process, so that's on the joint undertaking side. So what will happen once you have submitted your proposal on September 20? The next step will be an individual evaluation of the proposals, where experts, a minimum of 3 experts per proposal, will individually assess the proposals. Then they will, after this assessment, will come together in a so-called consensus group, where the aim is to agree on a common position, including comments and scores for each proposal. Then the next step is the review of the panel. This panel is composed of experts that, again, we aim to reach an agreement. They check for consistency across the evaluation, and then at the end they conduct the final ranking of the proposals. And then, as the finalization step, the Clean Hydrogen Joint Undertaking takes the opinion of the panel, reviews the results, and puts together the published, so the really final ranking list, and then they propose the date of May 20 next year that companies can expect to sign the grant agreement and then basically start with the project. If you are interested in one of the calls or in the work program in general, so what would be the next steps then? Yeah, it's as I said, I think several times already. So it's very important to read and analyze the call text carefully. What I just showed here was a snapshot of the main objective I could find when reading through the call text or analyzing the call text. But this is very important that you repeat this exercise to really have a first viability assessment. And then second step, try and seek for the right consortium composition. It's about analyzing the different value chain stakeholders and also clarify once you contact potential consortium partners, clarify the expectations to them and also from you, both for the preparation of the application and once the project is granted, so implemented. Once the consortium is set, the next step would be to scope the idea. So deduce the so-called funding pitch. What is the pitch with which you would like to convince an evaluator, for instance? So it's a more detailed viability assessment compared to the first step, and it's about building a credible path, from the problem you're trying to solve to the outcomes and impacts that your project will have. And then after this, let's say initial desk work, I might call it, you can start drafting and writing, for instance, the work packages, including milestones and timeline, and also defining the specific objectives of your project. So what you want to see after a 3 years project. This process, if it goes very fast, it takes 1 month. Usually it takes 2 months. So it's really not to underestimate this prior work prior to start writing and submitting the application, which usually takes another 2 months. If you now feel a bit overwhelmed or think, well, we might not have the time for let's say proceeding in this, let's say, efficient way. Of course, we at Nordic Innovators are experts in delivering different services regarding proposal preparation. We, for instance, do training sessions on proposal writing. We do sparring, coaching at any point of the process, at any point of the ones I just showed you in the previous slide. We do full or partial writing services. We have own Part B templates, which are designed based on our long year experience. We also offer review services. So once you have drafted a Part B template, for instance, we can review and give comments. So we basically do everything from small assistance to full service during the proposal development and writing phase. Yes, and with this, I'd like to thank you very, very much for your kind attention and looking forward to your questions. Thank you.
So we have a question on what's the average success rate for the clean hydrogen partnership?
Very, very good question and difficult to, let's say, answer because the numbers of submitted proposals usually are not that available as for other European calls. They, of course, usually a consortium-based project is submitted less frequent. So winning chances compared to single applicant proposals are higher. Here we're talking about above 10%. That's let's say a ballpark number we can provide. But let's say the exact success rate, also because there are so many different calls, it's almost impossible to answer. But yes, and the ballpark number is that the success rates for this project is above 10%. Other, just to give a comparison, other single applicant proposals have success rates below 1%.
You also see that in Clean Hydrogen Partnership as well as other PPPs in Horizon Europe, different calls who have different success rate because they're more competitive than others, and are more interesting for more a number of applicants. So there will be a varied degree of success rate depending on the calls.